Good morning, students. Today we'll see about the global system for mobile, that is GSM. So first we'll see about the GSM architecture. The GSM architecture consists of three major interconnected subsystems that interact among themselves. So the three important major interconnected subsystems are base station subsystem, that is BSS, network and switching subsystem, NSS, operating support subsystem, OSS. So these three subsystem forms the major system architecture for GSM. Apart from these three, we do have mobile station MS, which is also a subsystem, but usually this is considered to be a part of BSS. Okay. So now we'll see about the pictorial representation of GSM architecture. So this mobile switching center, MSC, and BTS and base station controllers or all will come under base station subsystem. So first we'll see about this. So BTS will be remotely distributed or physically connected to BSC by a microwave link or through a dedicated leased line. And BSC will hand over or reduces the load to mobile switching center. So all these are interconnected. So first, the mobile station subsystem will get connected, and then it will be passed on to the networking switching subsystem and then to the public network. So this is the basic hierarchy which should be followed. So now first of all, we'll see about NSS. So the NSS of GSM will handle the switching of GSM call between the external networks and the BSC into the radio subsystem. So it is responsible for managing and providing external access to the several customer database. So apart from doing all these works, the MSC in the central unit of the NSS control the traffic among all BSC. This is the major work of NSS. So all these things will be done. Apart from this, it also contains three different databases, which are home location register, that is HLR, visitor location register, VLR, and authentication center, AUC. So now we'll see all these things in detail. So the home location register contains the subscriber information and location information of each user which resides in the same city as the MSC. And also it contains the international mobile subscriber identity used in the home user. But the visiting location register will have temporarily stores this IMSI and customer information for each roaming subscriber who is visiting the coverage area of a particular mobile switching center. Okay. If a roaming mobile is logged into the VLR, that is visiting location register, then the MSC sends the necessary information to the visiting subscribers HLR, so that calls to the roaming mobile can be appropriately routed to the PSTN by HLR. Okay, so that is the use of visiting location register. Now, after this, we'll see about the authentication system center, which protects the database, which handles the authentication and encrypted keys for every single subscriber in HLR and VLR. So, AUC is the center which will have the equipment identity register also. Okay, so even if with the help of EIR, you can identify stolen phones which are not there in VLR or HLR. So that is the advantage of EIR, which is there in the authentication center. Next, we'll see about operating maintenance subsystem. So on the whole, it will maintain this GSM architecture. So maintenance means maintain all the telecommunication hardware and network operation, manage all charging and billing procedure, manage all mobile equipment in the system. So all this process will be done by OFC of the GSM system. So now we know what is the three major subsystems, how they are interconnected. So for interconnecting them, we should need an interface. So first, mobile station and BTS has to be connected with ABS interface, which connects BTS to BSC, which will carry the traffic and maintains the data specified by the GSM. And then from BSC to MSC, the interface will be taken care by A interface, which is having a dedicated leased lines or microwave links. Then from MSC to the PSTN, the signaling system number 7 is used to interface MSC and PSTN networks. Okay? So likewise, all will be interfaced and then communicated so that there will be a successful data transfer between the mobile station and another mobile subscriber. So for all these things, we should know about the frame structure of GSM. So this is the sample frame structure of a speech signal, which consists of 26 TDMA frames, which is called as speech multi-frame, which contains all time slots of 24. And this 25th and 26th will be I or S. I is an idle frame, or else it can be a control channel frame. So this is used as an identification, and the next set of frames will be followed after this IS. So this is the frame structure which has been used in the GSM architecture. To understand more about this, we'll see this. This is the time slot, which occupies of about 576.92 microseconds, which carries 156.25 bits, which starts from tail bit to quad bit. Apart from that, inside that, we'll have a coded bit, coded data, which has to be communicated. So this is one time slot. Such 8 time slots forms a frame. The total frame will have a time duration of 4.615 milliseconds. This one frame, like this, if 26 frames are grouped, it is called as multi-frame, which is having a duration of 120 milliseconds. Likewise, 51 multi-frames will be grouped together to form a super frame, which is 6.12 seconds. Okay, so like this is the general GSM frame architecture. So with all these fundamentals, all these blocks, functional and the frame structure, now we'll see how a speech signal is being processed in a GSM architecture. So assume that here is a speech signal, which is an audio signal. It has to be communicated to a distant apart. So this signal, which is an analog signal, will be digitized by either sampling, quantizing, and encoding it. After coding it, we have to go with source coding. Source coding will remove the unwanted bits, so that the number of bits will be reduced, so that it can be spectral efficient coding will be done. Later on in the channel coding, we will add extra redundant bit and we will increase the code rate. This is for security purpose. Then we'll scramble the bits. The burst formatting will be done, stripping, all these things for secrecy, it will be maintained, and then we'll modulate, we'll pass on to the channel. Via wirelessly, it will be reaching to the destination where the reverse process of transmitter will be taking place, where the appropriate demodulation, de-shifting, burst formatting, de-interleaving, channel decoding, source decoding will be done. And finally, the original speech signal, which has been transmitted in the transmitter side, will be received in the receiver side. So this is the GSM operation for transmitting a speech in one side, and it will be received in the other side. Students, hope you understand this today's topic, which is more interesting. So this is an important topic of your syllabus. We should know this. And now I hope that you understand this concept. So now I'll add few more questions for this to you, so that you can add, you can understand, and you can